Hello and welcome to York Observatory TeleTube, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. My name is Dorsa, and I'll be one of your hosts this evening, and I'm joined by Nicole, June, Huria, and Mariana, broadcasting live from L&I Carswell Observatory located at York University in Toronto, Ontario, Canada. York YouTube broadcasts every Wednesday night at 7:30 p.m. local Toronto time. And for any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email to observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory and Facebook at L&I Carswell Ups. Good evening, everyone. I'm Dorsa, and today we will be talking about the DART mission, or the Double Asteroid Redirection Test by NASA. But before jumping into it, we would like to say that the observatory at York campus is in Toronto, and we would like to welcome you all to our show and to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Toronto has been caretaken by the Anishinaabeg Nation, the Haudenosaunee Confederacy, the Huron-Wendat, and the Métis. It is now home to many Indigenous peoples. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. Our stargazing and astronomical efforts join the long history and current practices of astronomy for this land. The observatory looks forward to continuing to learn and revitalizing our knowledge in this area. And now I'm giving it away to my colleague, Mariana. Take it away.
Thank you, Dorsa. Welcome, everybody. Before we get started with our main show, we want to give you a little update about what you can see this coming week. The moon is in its waxing crescent phase with an illumination fraction of 1.25% as seen from Earth. Even though only a small part of the moon is illuminated in this phase, you can sometimes faintly see the rest of the moon. This phenomenon is known as Earthshine, and it begins after the noon moon phase, which was yesterday on October the 25th. The waxing crescent phase will last for 7 days, and during these 7 days, the right edge of the moon will become brighter as it approaches the illumination fraction of 50%, i.e. the first quarter moon phase. The sunset tonight was at 6:18 p.m. EDT, and there are still many objects in the sky to see. Starting off with Jupiter, which became visible a little after sunset today, as well as Saturn. Both of these planets can be viewed with the naked eye. Look for the brightest object in the sky that's not twinkling and that's not the moon, and that would be Jupiter. Saturn follows Jupiter by being the next brightest object in the sky. Both would be located east-southeast in the sky, and although you can see it without any fancy equipment, binoculars or a small telescope would make them even more pronounced. Just yesterday, on October the 25th, there was a partial solar eclipse. This occurs when the moon passes between Earth and Sun and thus partly obscures Earth's view of the Sun. This can only be seen from certain places on Earth, like in Europe, West Asia, Northeast Africa, and the Middle East. However, there are many videos and pictures taken of this event, so if you are not located in those areas, you can always see it online. We are lucky because this week is the best time to look at Mars, which rises around 9 p.m. EDT. This is because during this time, Mars, which is with its noticeably red color, will continue to increase in brightness. Again, this planet will be brighter than most stars in the sky and can be seen with the naked eye as well. But the use of a telescope and/or binoculars for viewing are always encouraged. Another amazing phenomenon that can be seen in the sky this week are two open clusters. The open cluster NGC 869, known as Percy, makes up the western half, while NGC 884, aka X Percy, makes up the eastern half. These deep sky objects have magnitudes of 5.3 and 6.1 respectively, and can be seen with a small telescope or binoculars. These objects will be visible all week long, so make sure to get outside and look up at the stars. Now, I would like to give it away to my colleague Puria.
Thank you so much, Mariana. So, hello everyone, and good evening. Today's TeleTube topic is around NASA's most recent mission, which you might have heard about. This mission is called the Double Asteroid Redirection Test, or DART, if you want to say it in short. First thing that I'd like to talk about is the importance of the planetary defense system and why it is so significant for any living being. This system marks a critical role in our assessment of the future impact hazards caused by astronomical objects like asteroids, meteorites, comets, and etc. Developing spacecrafts and satellites that will aid us in protecting our planet Earth would be a priority in space agencies all around the world. Therefore, we can say that the understanding behind such objects would guide scientists and engineers to create and build up solutions that would prevent tragedies similar to that of the dinosaurs millions of years ago. Since the day the Earth was born, this planet has always been under the threat of dangerous space objects that can cause enormous damage in case they collide with our planet. The threat can be so big that it can end all lives on the planet. One famous example is the collision of an asteroid that ended the age of dinosaurs. So, in order to prevent future disasters similar to this, NASA scientists have started the DART operation. The DART mission was a test conducted by NASA as its first mission in the field of planetary defense systems. The purpose of this mission was to make a satellite collide with an asteroid to change its speed and direction of movement. The name of the asteroid that they intended the satellite to collide with is Dimorphos, which was about 11 million kilometers away from Earth at the time of the impact. In addition to its being the first planetary defense attempt, it is also the first mission to intentionally make a satellite crash into a space object millions of kilometers away from home. Considering that we are living in the space age, in the near future, we might have to rely on this method to defend ourselves from the threat of asteroids that threaten us. We cannot wait to see how we will improve in the planetary defense system department, and hopefully we'll be able to have successful missions like DARTs more in the future for the sake of our home. Now, I would like to give the rest to my colleague June. June, take it away.
Thank you, Puria, and hello, everyone. Let's talk about DART in action. How did the mission go down? What have we learned so far? Did this method prove reliable? And most importantly, did we do right by the dinosaurs? The DART mission left home on a SpaceX Falcon 9 rocket in the early hours of November 24th, 2021. Mission controllers found that the new next ion thruster engines suffered a safety fault, which led to it being turned off for the remainder of its 10-month journey to its target, the Didymos system. This ended up being fine since the Falcon 9 did spectacularly in sending DART on its way. Had DART actually missed, operators would have just engaged the next thrusters and reattempted the test 2 years later. In this July, the Draco camera located Didymos from approximately 32 million kilometers away as a 1.4 pixel wide speck of light. The teams tested their pointing and camera Draco along the way, catching views of M38, Jupiter, and Europa. Then, on the 11th of September, the Leica Cube, a CubeSat, was released in preparation for its impact reconnaissance mission 15 days later. But ultimately, we're here for the impact. Traveling at a relative 6.6 kilometers a second, DART slammed into Dimorphos, imparting 11 gigajoules of energy. Beaming back 1 image per second, the GIF on the right is a time lapse of the impact as seen by Draco, the camera. You can see it zoom past Didymos and lock onto Dimorphos for a direct hit, causing the final frame to be cut off prematurely. But the mission team wanted an even better view of their beam. Maybe it was to get a better idea of the impact parameters. but I'd like to think it was for the visual satisfaction of avenging the dinosaurs over 65 million years later, and the knowledge that we can keep our home safe from rolling space rocks. Hubble and JOWST made high-resolution time lapses of the impact in ejecta, and the ATLAS team, along with the South African Astronomical Observatory, gave us a much larger and longer view of the ejecta cloud being blown and thrown off. Now, not to forget about the Leica cube. This is a contrast stretched mosaic of the impact shortly after, as seen by Leica. The main asteroid is dwarfed by the size of the ejecta filaments, showing just how much debris was liberated from Dimorphos in this impact. All right, let's get back to the science part of the mission. Did it work? Is this a viable way for us to keep the remaining dinosaurs, our birds and crocodiles, safe from big space rocks? Well, my dear parrot Lindsay can sleep easily because the answer is a resounding yes. We expected a minimum successful orbital change of about 73 seconds, but we changed the orbital period of Dimorphos by 32 minutes. What an impactful change. Now, ESA's Hera mission in a few years will give us a better understanding of what happened and some up-close pictures of the cratering left behind to give us such an efficient momentum transfer understanding here. In the meantime, we can look at the magnificent debris tail the asteroid system now sports, elongated by solar radiation to over 10,000 kilometers in this image shortly after impact. Astronomers worldwide, well, will continue to monitor the asteroid, and we can be reassured that this class of asteroid can effectively be deflected from given enough warning time. In the meantime, we're out of time, for this TeleTube broadcast at least. So I'm going to hand things over to Nicole and finish things off.
Well, everyone, you have been listening to Alani Caswell's Observatory Weekly Creative Podcast, the Astronomy and Astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. The host this evening I have been Dosa, June, Mariana, Poria, and myself, Nakul. Make sure to leave any comments or questions in the comment section of the video and talk to us in the chat right now. We will be around for next 20 minutes to answer your questions. All of our programs are free, but if you like to make a donation, see our website at observatory.info.yorku.ca. You can always connect with us with the Twitter handle at York Observatory and check out our website for show notes, content, updates, and contact info at observatory.info.ca. Thanks for tuning in, clear skies, and have a good night.